Hello friends, my name is Kausalya. Welcome back to our class. In the last episode, we have learnt about LCM. And in today's episode, we are going to solve a few problems based on LCM. And all the questions that I am going to solve today have appeared in some or the other government exams in the previous years. So let me read the question for you. What is the least number which when divided by the numbers 3, 5, 6, 8, 10 and 12 leaves in each case a remainder 2, but when divided by 13 leaves no remainder? What does it mean? There is a number, let's consider it as x. And when this number is divided by either 3, 5, 6, 8, 10 or 12, we get a remainder 2. When the same number is divided by 13, the remainder will be 0. So now we have to find out which number is this and what method are we going to use. Now what is that number which when divided by 3 and 5, you get a remainder 2. It can be 15 or it can be 30. To that you can add 2. So it can be either 17 or 32. So when you divide it by 3 or 5, you get a remainder 2. Now we should take such a number which when divided by all these numbers should get a remainder 2. So what is the best way? Take the LCM of all these numbers. Now how do we take the LCM? You must have seen our last episode. You first consider the highest number among these and then take the multiples of that number. Now when you take the multiple of 12, it has to be divided by 10. So which means the first number that you can consider is 60, right? Now if you consider the number 60, it will be divided by 3, 5, 6, 10 and 12 but not by 8. So let us consider a number which is of tens in the 12th multiples. So the next number will be 120. So 120 will be divided by 3, 5, 6, 8, 10 and 12. So 120 is the LCM and we are going to consider 120. To that we will add 2 because we want a remainder 2. Now if you take 122, it will be divided by all these numbers, then you get a remainder 2. Now there is one more condition given in the question, which is if you divide the same number by 13, then you should get the remainder 0. Now are we sure that if we take 122, it will be divided by all these numbers and get 2 as remainder, plus if it is divided by 13, we will get a remainder 0. Now what is that number which satisfies this condition? It is 120 plus 2, or it can be any multiples of 120 like 240 plus 2. So it can be written as 120 into, let's consider this any number as 2 which will be the multiples of 120, then plus 2. Now what is the second condition they have given us? The same number has to be divisible by 13. Means when you divide that number by 13, the remainder will be 0. Now which is the closest number to 120 which is divisible by 13? That is 117. So let us write 120 as 117 plus 3 into a plus 2. So this will become 117a plus 3a plus 2. Here this entire number has to be divisible by 13. 117 is anyway divisible by 13 because 13 nines are 117. Now if you consider 3a plus 2, this has to be also divisible by 13, which means 3a plus 2 has to be divisible by 13. Now, which is the first number that you can think of 13 multiple? If this number has to be 13, then 3a has to be 11. which is not possible. So let us consider the second multiple of 13, which is 26. So now if you consider 26, which is the second multiple of 13, this entire number has to be 26, for which 3a has to be 24, which means a will be 8, right? 3 into 8 is 24. So a will be 8. So in this case, the least number will be 8 in place of a. So 120 into 8 plus 2, when we consider that number, will be divided. When divided by all these numbers, we will get the remainder 2, and when we divide it by 13, we get remainder 0. So what will be that number? It will be 120 into 8 plus 2. So 8 12s are 96. So this is 960 plus 2, 962. So now let us see the next problem. Now let us read the next question. The traffic lights at 3 different road crossings change after every 48 seconds, 72 seconds and 108 seconds respectively. If they all change simultaneously at 820 hours, then at what time will they again change simultaneously? So what do you understand from the question? There are 3 traffic signals wherein they all have different time. Like the first signal will change at every 48 seconds, the second signal will change at every 72 seconds and the third signal will change at every 108 seconds. Now let us consider if all the signals have been open at 820 hours, which means at 820 48 seconds the first signal will change, the second signal will change at 821 12 seconds and the third signal will change at 821 48 seconds. Now we have to find out at what time will they again change simultaneously. Now when you see these 3 numbers, you should immediately remember these are the multiples of 12s. 12 into 4 is 48, 12 into 6 is 72, 12 into 9 is 108. So at LCM of these 3 numbers is when they will simultaneously change. Now this can be written as 12 into 4. This is 12 into 6 and that is 12 into 9. Now you have to find out the LCM of 4, 6 and 9. Now what is the LCM? You have to first consider the highest number of these 3, so which is 9. So 9 is not divisible by 4 and 6. Then the second multiple of 9 is 18, which is also not divisible by 4 and 6. So the first number that you can think of which will be divisible by both 4 and 6 will be 36, right? So this will be 12 into 36. Why? Because 36 is the LCM of 4, 6, 9 and we need to find out the LCM of 48, 72 and 108. So it will be 12 into 36. Now how do we do 12 into 36? You can watch our previous videos wherein using Vedic Mathematics Sutra we have told how to multiply 2-digit numbers. So 6 into 2 is 12, 2 here, 1 carry forward. 3 into 2 is 6, 6 into 1 is 6, 6 plus 6 is 12, 12 plus 1 is 13, 3 and 1 carry forward, 3 into 1 is 3, 3 plus 1 is 4. So 432. Now 432 is the LCM of these 3 numbers. How can we write 432 as? We can write it as 420 plus 12, right? Why am I writing it as 420? Because we need to have it in 60s multiple because we are writing it in hours and seconds format. So 42 is divisible by 6. So 6 sevens are 42. So that's how I have written. So this will be 7 minutes and 12 seconds. So which means at 8 hours 27 minutes and 12 seconds, all these signals will simultaneously change. I hope you all understood. Why did we take the LCM here? Because here there is 48 seconds and they've said at what time they will change simultaneously. So if it is 48 seconds, at 48 into 2 it will change the second signal, 48 into 3 the third time, 48 into 4 the fourth time. Similarly 72 into 2, 72 into 3, and exactly similarly 108 into 1 into 2 into 3 and so on. So we have to first find out the common interval where all these will change simultaneously and then the earliest one. So that's why we took the LCM of these three numbers so that we could find out at what time they will all change again simultaneously, which is 8 hours, 27 minutes and 12 seconds. Okay, let's go through the next question. Seema, Meena and Reema begin to jog around a circular stadium and they complete their revolutions in 54 seconds, 42 seconds and 63 seconds respectively. After how much time will they come together at the starting point? Now what is the question? There are three girls who are jogging in a circular stadium. This doesn't look like circulars, but consider that this is circular stadiums. Now the first girl completes her revolution at 54 seconds, right? So her second revolution will be 54 into 2 and then 54 into 3, right? The second girl completes her jog at 42 seconds, the first revolution. The second will be 42 into 2, 42 into 3 and so on. And the third girl will finish her revolution at 63 seconds. And 63 into 1, 2, 63 into 3 and so on. Now we need to find out at what time all three will meet at the starting point again. Before solving this question, let me explain this to you with a simpler example. Consider there are only two people and then first one finishes her jog at 2 seconds and the second one finishes her jog at 3 seconds. When will they again meet at the starting point? At 6 seconds, right? And then the next cycle will be at 12 seconds. They'll meet the third time and then 18 seconds and so on. How did we get this? It is the LCM of 2 and 3. Now the similar logic will be applied in this question also. So we have to find out the LCM of 54, 42 and 63. Now it's a big number, so let's simplify that. Let's write 54 as 6 into 9, 42 as 6 into 7 and 63 as 7 into 9. Now from this we'll take common. So we'll take 6 and then we'll take 7 and 9. 6 into 7 is 42, 42 into 9. Which is 378, which means at 378 seconds. So how can you write 378 seconds as 360 plus 18 seconds. So this is 6 minutes and 18 seconds. At 6 minutes and 18 seconds, all three of them will meet at the starting point. I hope you all understood this question. It's quite interesting. So in today's episode, we have solved 3 questions based on LCM and keep practicing. In the coming episodes, we will solve more questions based on LCM. Until then, keep watching us. If you have liked the video, hit the like button, share it with your friends, and you can write the feedbacks through the comment box. And don't forget to subscribe to our channel. Happy practice, happy maths.